Hey everyone, and welcome back.
Yeah, welcome back.
Today we're going to do a deep dive into something that can really help you level up in your career,
hmm
and that's prepping for an Entity Framework Core interview.
Ooh, yeah, those can be tough.
They can be tough, right? And we're not talking like beginner stuff here. We're going for those intermediate to even advanced concepts that really make you stand out.
Exactly. It's about showing that you really get EF core, not just the surface level.
Okay, so we've got a set of questions and answers that we're going to use as a jumping off point. And the goal here is to not just like give you the answers, but to really explore the why behind them.
Love it.
So you can walk into that interview with confidence.
All right, let's jump in.
Okay, first up is question 21, and it's all about transactions.
Oh, yeah, a classic.
A classic, right? The question is, explain the concept of transactions in EF Core. How are they managed?
Okay, so first, think of a transaction like a safety net for your data. It ensures that a set of operations, they either completely succeed or they completely fail.
All or nothing.
All or nothing as a single unit, which is really critical when we're talking about keeping our data consistent and correct.
Makes sense. So how does EF Core actually manage these transactions? Like what's happening behind the scenes?
So there are two main ways. We've got implicit transactions, which are handled automatically by EF Core whenever you call that save changes method.
That's like a built-in safety feature.
Yeah, exactly. It's like EF Core is wrapping all your changes into a single transaction for you.
Nice, so we don't even have to think about it most of the time.
Right, but here's where it gets interesting. You also have the option to manage transactions explicitly.
Okay, now why would we want to do that if it's already happening automatically?
Great question. So imagine you have a complex operation, right? Like you're transferring money between bank accounts. You need to make sure both the debit and the credit happen together or not at all. That's where explicit transactions come in.
Got it, so it gives us more control in specific situations. That's good to know. I'm starting to see how these questions aren't just about like spitting out an answer. It's about showing that you understand the bigger picture.
Absolutely. You want to demonstrate that you can apply these concepts to real-world problems.
Okay, let's move on to question 22, which is about shadow properties. Now, I've always found the name shadow properties a bit mysterious. What are they? Why would we use them?
So shadow properties are kind of like these hidden compartments in your database. They store information that's important for your application, but maybe you don't want it directly exposed in your entity's structure.
So it's like behind the scenes data.
Yeah. A common use case is for audit information, like tracking who created a record and when.
Okay, so instead of cluttering up our entities with those extra properties, we can tuck that information away in shadow properties.
Exactly. It keeps things clean.
Yeah.
But what's cool is that they're not just for audit info. You can use them for storing calculated values, timestamps for data integrity, or even to support specific features of your database provider.
I see. So it adds a lot of flexibility. How do we actually create and configure these shadow properties in EF Core?
You do it through the Fluent API. It's basically like telling EF Core, hey, this property is a shadow property, and then defining its type and behavior.
Got it. So it's a bit of a behind-the-scenes configuration.
Exactly.
Now, even though they're hidden, can we still access these shadow properties?
Absolutely. You can access and manipulate them through EF Core's change tracking and update mechanisms.
Makes sense. Okay, ready for question 23?
Hit me.
All right. It's about raw SQL queries in EF Core. Now, I know some developers are hesitant to use raw SQL when they have EF Core to work with, but why would we ever need to go that route?
Yeah, it's definitely a topic that sparks some debate. But sometimes raw SQL just makes sense. Like if you have a really complex query involving multiple joins or maybe some specific database functions that EF Core doesn't translate into LAMQ very easily.
So it's like our escape hatch when we need that fine-grained control.
Oh, yeah, exactly. But we do need to be careful about things like SQL injection vulnerabilities and potential portability issues if we're working with different database providers.
Security and portability, always important.
Always. Understanding when and how to use raw SQL effectively is a great skill to have.
Agreed. Okay, on to question 24, which is all about entity states.
All right, bring on the states.
Now, whenever I hear entity states, my mind goes to like relationship statuses on social media, but I have a feeling this is a little bit different.
It is, but maybe we can still use that analogy.
Okay, I like where this is going.
So imagine an entity as a person going through different stages in their relationship with the database. We have states like added, unchanged, modified, deleted, and detached.
Okay, so added means it's brand new to the database, and
Uh,
unchanged means Well, nothing's changed.
Exactly. Modified obviously means something has been updated. Deleted means we're saying goodbye. And detached is like the entity is taking a break from the database.
I love that. So it's like EF Core is keeping tabs on where each entity stands in its relationship with the database.
Yes. And it uses those states to figure out how to handle the entity when you call save changes.
That makes a lot of sense. Okay, let's move on to question 25, which is about query performance, something I think every developer wants to improve.
Absolutely. Performance is key.
The question asks, what are some techniques to improve query performance in EF Core? So let's hear it. What are your top tips?
One of the biggest things you can do is use ASME tracking when you're just reading data and not planning to make any changes.
So we're basically telling EF Core, hey, you don't need to keep track of all these entities. I'm just looking.
Exactly. And that can significantly reduce the overhead and make your queries much faster.
Awesome. Any other tips?
Another key technique is to be selective about the data you retrieve. Don't grab everything if you don't need it. Just select the specific columns you need. This reduces the amount of data that needs to be transferred and processed.
So it's like ordering a la carte instead of the whole buffet.
Perfect analogy. And of course, we need to be mindful of those dreaded N+1 queries. Remember those?
Oh yeah, we've talked about those before. They can be a real performance killer.
For sure. So if you know you're going to need related data, make sure you're using eager loading with the include method to fetch everything in one go.
Include is our friend.
Include is definitely our friend when it comes to performance.
Okay, I'm feeling like we're building up a whole toolbox of performance optimization techniques here. This is great.
We are, and there are even more advanced techniques we can explore, but these are some of the most fundamental and impactful ones to master.
Awesome. Okay, we're going to take a quick break, but when we come back, we've got even more EF Core interview questions to tackle.
Can't wait. Okay, so let's jump into another set of questions that often come up in EF Core interviews. These are about managing entities and understanding how EF Core keeps track of those changes.
Okay, sounds important. What do we have?
All right, so question 26 asks about the difference between add, attach, and update.
Oh yeah, I remember struggling with those when I first started learning EF Core.
They can be a bit tricky, right? They all kind of seem to be doing the same thing, but there are some subtle differences.
Yeah, can you break it down for us?
Sure, think of it like this. Add is like creating a brand new file on your computer. You're introducing a fresh entity to EF Core and saying, hey, this is new, track it and add it to the database.
Okay, makes sense. What about attach?
Attach is more like opening an existing file. You're saying, I already have this entity. I just want you to start tracking it.
So it's for entities that EF Core isn't aware of yet.
Exactly.
Got it. And what about update?
Update is like hitting the save button on that file. You're telling EF Core, this entity has been modified, update the database.
Okay, so it's all about managing the life cycle of our entities and how they interact with the database.
Exactly.
All right, next up is question 27, which asks about lazy loading. Now, I've always thought of lazy loading as kind of like a fetch-as-you-go approach to data retrieval.
Yeah, that's a good way to put it. Instead of eagerly fetching all related data up front, it delays loading until you actually need it.
So it's all about efficiency.
Exactly. The main benefit is improved initial query performance, since you're not loading everything at once.
That makes sense. But are there any potential downsides to this approach?
Well, the biggest concern with lazy loading is the potential for N+1 queries. If you're not careful, you can end up making a separate query for each related entity.
Right, we talked about those earlier. They can really slow things down.
For sure. So if you know you're going to need related data, it's often better to use eager loading with the include method.
To fetch everything in one go.
Exactly. It's all about choosing the right strategy for the situation.
Speaking of eager loading, question 28 asks about the differences between lazy loading and eager loading.
Yeah, so to recap, lazy loading fetches data on demand, eager loading fetches everything up front.
So each approach has its pros and cons.
Exactly. Lazy loading can improve initial query performance, but risks N+1 queries, and eager loading avoids those extra queries, but it might mean a larger initial query.
Got it. Okay, question 29 takes us into the realm of change tracking.
The detective work of EF Core.
Right. The question asks, how does EF Core keep track of changes made to entities? So what's going on behind the scenes?
So whenever you retrieve an entity from the database, EF Core takes a snapshot of its original values, and then as you make changes to that entity, It's keeping track of those changes.
So it's like EF Core is constantly comparing the current state of an entity to that initial snapshot.
Yeah, pretty much. And the reason it does that is so that it can generate efficient SQL statements when you call save changes.
That makes a lot of sense. It knows exactly what needs to be updated.
Exactly. Understanding how change tracking works is crucial for writing efficient EF Core applications.
Okay, last question in this section is number 30, and it's about ASNO tracking.
One of my favorite performance optimization techniques.
Right. The question is, when should you use ASNO tracking in EF Core?
So ASNO tracking basically tells EF Core to disable change tracking for the entities you're retrieving from the database.
Okay, and when would we want to do that?
Whenever you're reading data and you know you're not going to be making any changes to those entities, it can significantly speed up your queries, especially when you're working with a large data sets.
So it's all about telling EF Core, hey, I just need to read this data. No need to keep track of every little change.
Exactly, and that can make a huge difference in performance.
This has been super helpful. I feel like I'm starting to really understand some of these key EF Core concepts.
Me too. And remember, the more you understand the why behind these things, the better prepared you'll be for those tough interview questions.
Absolutely.
Okay, ready for a couple more?
Bring it on.
All right, let's wrap up with a couple more questions that might throw you for a loop in an interview. These are a bit more advanced, but they really show you understand the ins and outs of EF Core.
Ooh. Okay. I'm intrigued. What do we have?
Okay, so question 31 asks about concurrency conflicts. The question is, what are concurrency conflicts in EF Core and how can they be handled?
Concurrency conflicts. That sounds like something that could cause problems.
It definitely can. Imagine two users trying to edit the same record in the database at the same time.
Oh, yeah, that wouldn't be good.
Right. Let's say they both grab the same product info, make changes, and try to save those changes back to the database. Whoever saves last wins, and the other user's changes get lost.
Yikes, that could lead to some messed up data.
Exactly. It's called a concurrency conflict, and it's a big deal for data integrity.
So how does EF Core help us deal with this?
Well, EF Core has some built-in mechanisms for handling concurrency conflicts. One common approach is optimistic concurrency control. Basically, we use a concurrency token, like a timestamp or a row version, to track changes to a record.
Okay, so we're adding like a version number to our data.
Yeah, kind of. So when a user tries to save their changes, EF Core checks that token, and if it's changed since they retrieved the record, it means someone else has modified the data in the meantime.
Ah, so it detects a conflict.
Exactly. And then EF Core can handle it in a few ways. It can throw an exception and alert the user, or it can try to automatically merge the changes.
So we have options for how to handle those conflicts.
Yes, and understanding these concurrency control mechanisms shows that you really get data integrity and how to handle things in a multi-user environment.
Okay, makes sense. What's our last question?
Last but not least, we have question 32 about the unit of work concept.
Unit of work. Okay, that's a new one.
It's a design pattern for managing a series of database operations as a single transaction. And guess what? EF Core's DB context actually implements this pattern.
Really? I didn't realize that.
Yeah, so it gives you a way to group multiple changes and commit them all at once.
So instead of making a bunch of separate trips to the database, we can bundle everything together.
Exactly, and this is especially important when we have complex operations involving multiple entities.
Right, it keeps everything consistent.
Yes, understanding the unit of work pattern and how DB context works with it is a valuable thing to know.
Wow, this has been a seriously deep dive into EF Core. I feel like we've covered so much ground, from basic concepts to some really advanced stuff.
It's been fun, right?
Definitely. And I think our listeners are going to walk away feeling much more prepared for those EF Core interviews.
I hope so. Remember, the key is to not just memorize answers, but to really grasp the why behind these concepts.
Couldn't agree more. And remember, practice makes perfect.
Exactly. Keep practicing, keep learning, and you'll be acing those interviews in no time.
Absolutely. Thanks for joining us on this deep dive, everyone. Be sure to check the show notes for links to some helpful resources. And until next time, happy coding.